All right, recording is re-rolling. We're in the last about 8 minutes of class, and I'm gonna go over the solution with you guys. Now, a lot of you guys didn't remember that I did hand you guys this very convenient table that could solve the whole thing for you. There's one column missing, which is for the mass of the ball, right? But if you include the mass of the ball, right, which you would measure with the scale, then but I gave that to you guys. I said just call it 6.4 grams, which is called 0.0064 kilograms. Okay. Then you really only need 3 measurements to get this whole thing. Like you guys know gravity is 9.8 meters per second squared. You just use that. Okay. You need to measure the height of fall with the meter stick right here. You need to measure where the ball landed, horizontal displacement, also with the meter stick. And also what was the spring compression of the launcher? What was X for the launcher that would feed into 1/2 keg squared? Right? And then you can do the whole thing based on that. Right. So you guys got colored pencils ready to go? Colored pencils?
Pardon the interruption, teachers. Can we please have all 10th grade students to the auditorium at this time? All 10th grade students to the auditorium at this time. Teachers, please hold your other students until the first period bell has rung. Thank you.
All right, so guys, if you're a 10th grader, then take your lab, just watch this recording and grade it and just bring us back tomorrow. Is that okay? Because it's gonna be about just a few minutes because we only got a few minutes till bell, right? All I know is that I saw an email just says presentation, so I don't know what it's about, but yeah, if you're 10th grade, then take off and go see you guys. And you can just grade this at home and bring it back. Right, get you a quiz too. Here, if you're a 10th grader, you can pick up one of these quizzes. And if you're 11 to 12, I'll get one to you before the bell rings. All right, so let's go over the solution. All right, so part 1, question. What is, let me see when we guys see this. What is the spring constant of the launcher? But I gave you guys the question, so all you had to do is copy paste what I wrote to you already. Okay, so go ahead and pick up a quiz on the way out. You got a quiz. Okay. All right, you can do the whole thing with 2 measuring tools. You need, you could have said a scale or a triple beam balance, some way to measure the mass, right? And also some way to measure distances. Meter stick was probably the best choice. You could have said a ruler. I forget what that rolling thing is called, but yeah. Okay, so you can do the whole thing with those 2, right? All right. I've got actually 2 ways to do this, but I'm sort of leading you guys down this track. So let's just focus on this one. Okay. All right, so you have to know that gravity is either 9.8 or 10 meters per second squared. You have to use that, right? We're ignoring air drag, right? So probably a good idea to mention that. Okay. So if somewhere in your calculations you have gravity is either 9.8 or 10 meters per second squared, go and give yourself a point. So we're up to 4 points right now. 1 point for the question, 1 point for the scale or triple beam balance, 1 point for a meter stick or a ruler, and 1 point for just having gravity somewhere in your calculations. Is that okay? All right, so we're up to 4 points. All right, give yourself a 5th point for mentioning the measuring the mass of the ball. Right, which again, I gave you guys to save some time, but you would want to write that in your procedure because yeah, have to have that in your calculation. Okay, it makes a difference. Okay. Okay. So that's the 5th point. Okay. You would want a brief description of, yeah, you set it on the lid, aim it horizontally. And then say we're up to 1, 2, 3, 4, 5. Okay, give yourself the 6th point for saying that you measured the height of fall, the height of fall. Okay. Right. I'm going to skip this one, come back to it because this actually belongs to the analysis. So come back to that one. Okay. Give yourself a 7th point for saying that you measured the distance, the horizontal displacement, the distance, D, where this ball landed. Give yourself an 8th point for saying that you measured the spring compression in meters, right? How far did the spring compress? It's probably a few centimeters, maybe 3, 4, 5 centimeters, somewhere there. Okay. Actually had 3 different settings, didn't it? Click, click, click. So you guys got that? All right. That's all the measurements, right? The mass of the ball, the height of fall, the horizontal displacement, and the spring compression. Right? You guys got all those? Okay. All right. Now let's go back to calculating the, are you guys ready for analysis? Right. Here's your first analysis step. Use height of fall as 1/2 GT squared. Right. That's true for dropping or aiming horizontally. Okay, to calculate the time of fall. Right. Now, if you use the full 4 meter ledge, not everybody did, but a lot of you guys did, then the time of fall should be just a little bit less than 1 second. Okay. Right. Is that right? Okay, so that's a point. Okay. Then now that you know the time of fall, because you calculated that, right? Nobody used a stopwatch. You calculated time fall based on the height of fall. Okay. And you know the horizontal displacement, which you measured. Can you do horizontal displacement divided by the amount of time to get the blast speed, which is, same thing as horizontal component of velocity is the blast speed, right? Okay. And you, if you want terms of variables, it's this expression here. The blast speed is the horizontal displacement times the square root of g divided by 2h. If you go back to your original measured and known values, if you want like a master expression. Okay. But of course, if you guys just have the numbers, that's fine. Okay, so you guys figure out the blast speed, right? That's worth a point right there. You guys got the blast speed, point for the blast speed. Okay. Right. So I think that's up to 10 points by now. And so there's 2 points to go. Okay. 1 point is to use conservation of energy to calculate the spring constant. Okay. So 1/2 kx squared equals 1/2 mv squared. Now that's just going from this point to this point. Here's your point A to point B, right? Initial to final. Right? Notice I'm ignoring the height drop because we're beyond that now. Initial to final. Okay. So kinetic energy, spring potential energy turns into kinetic energy. Right. And if you solve that, then you should get the spring constant. So give yourself a point for at least setting up this conservation of energy. Okay. If you solve for k is m times v squared divided by x squared, where x refers to spring compression. And if you tie that back to original variables, you get this one here. So k is equal to the mass of the ball times the gravity field of the planet times the horizontal displacement squared divided by 2 times the height of fall times the spring compression squared. Okay. So in terms of things that you can measure or know, that is like a master expression that could tell you the spring constant. Okay. Right. And that's a good skill to have to be able to do that right now. If you didn't have it in terms of variables, that's fine. You don't lose points, but that's a good thing to be able to do, right? Okay. And then you should get a spring constant in newtons per meter. I was running around checking you guys' papers before I started this recording again. It looks like you guys are getting numbers in the hundreds, which is good because that's a believable value. You've got like 150 newtons per meter. It's like, yeah, okay, I can believe that. Sounds about right. Okay. Right. So final point is for a conclusion. K equals something in newton per meter. And if you got something in the hundreds, then that's a really good sign. Okay. All right, you guys good? All right. So here's the last thing. Score yourself out of 12. I'm gonna pass out your guys' next open notes take-home quiz, which is going to be due on Monday. Okay. And then turn your graded lab into the grade tray before you guys walk out of the classroom. Okay. And that is what we got today. That will get okay. It should total out at 12. I was counting 12. Here, let me get you guys this quiz, and then I'll go look at that.
Are you gonna grade?
Yes, you got the write up, right? Okay. Yeah, so you scored your write up out of 12, and then you can put that to the grade tray. Yeah, guys, turn in your scored lab to the grade tray. You scored yourself out of 12, turn it into the grade tray.